Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, I'll explain what centering is, and I'll show you how to do it and talk about why it's useful in linear regression. So recall from the smoking example that when we interpreted the intercept was a nonsensical value because it gave us a value of the number of cigarettes smoked with 0 years of smoking. So it was when the predictor, X, or year smoking, had no meaningful zero value, because everyone in our sample had been smoking for more than 0 years. What centering does is it rescales the predictor to create a zero value, and usually we create that zero value at the mean. So how we do this is for every observation, we subtract the mean from the value. Centering does not change the slope. Let's take a look with the smoking data at what centering our predictor would look like. Now, I want to note also that we only ever center our predictors. We're not going to center our outcomes. And that will become clear once we take a look at scatter plots and the results from analyses with centered predictors. So here I've shown you the actual data, and in the data in the table on the right, we can see the original raw variable of years smoking in the first column, and in the second column is the centered data. So centering is essentially, as I said, subtracting the mean from each score. So for example, in the first row of the data, that participant had been smoking for 8 years, and 8 is actually the mean of years smoking. So we subtract the mean of 8 from the score of 8, and now their score on the centered variable years smoking is 0. Their score is now at the mean. So a score of 0 means at the mean. For the next row, a person who has been smoking for 11 years, they've been smoking for 3 years more than the average in the sample. So now their score on the centered variable is 3, and so on. To center data, we can actually use the compute variable command in SPSS, which you've already learned in class. To do this, I've created a new variable, years smoking underscore C, which is the centered variable. And I compute it by subtracting the mean of 8 from years smoking. So this subtracts 8 from each score for each person on years of smoking. Centering yields a variable in deviation score format. This means that the mean of the new deviation score variable is equal to 0, but the standard deviation is going to be the exact same as in the uncentered data. This is how it differs from standardizing a variable. We don't now have a mean of 0 and say a standard deviation of 1 or some other standard deviation. It's the exact same standard deviation, we're just changing the mean. So now a mean of 0 indicates average in the data. Let's take a look at what a comparison of the scatter plots would look like. So the scatter plot on the left is the scatter plot when we had the raw year smoking variable. And this is what the data look like. So we've got years of smoking on the x-axis and number of cigarettes per day on the y-axis. The mean now for the x variable, years smoking, is equal to 8. Now if we take a look at the scatter plot on the right, when we've centered the data, all that has changed is the scale of the x-axis. So now the mean of x is equal to 0, and that actually indicates average number of years smoking in the sample. And the plots, if we look at the plot comparison, each point looks the same. So it's not changing the regression slope or the relation between x and y, it's just changing the scale of x. We can compare the results as well from using a raw predictor and a centered predictor. If we look at the results, the only real difference of note is how the intercept coefficient changes. So this is important. So how the intercept coefficient changes is originally in the results using the raw predictor, we had an intercept of 4.095. And the way that we interpreted this was to say that a person with 0 years of smoking would smoke 4.095 cigarettes per day. And this is a nonsensical estimate. Now, when we use the centered predictor, if we look at the intercept from the results with the centered predictor, the new intercept is now 10. Now, this is saying that a person who had been smoking on average, at the average, which would be 8 years, smoked 10 cigarettes per day. And if you recall from the descriptive statistics, that's actually the average of the outcome. So now the intercept is interpretable because it's telling us what the average of the outcome is. It's essentially the average number of cigarettes smoked for the average, for a person with the average number of years smoking in the sample. Now, if we look from one table to another at the coefficient below, if we look at the regression coefficient or the B1 parameter estimate, it does not change at all. The actual B1 coefficient stays the same. It's 0.738 in either sample. So the only reason we center predictors is to have an intercept that gives us some meaningful information. So in the analysis with the centered predictor, this is how we would interpret those results. We would have an intercept of 10, and we would say that this is the predicted number of cigarettes for an individual with the sample average number of years smoking. Remember, that's 8. And then the interpretation would stay the same for the B1 coefficient as it was for the initial regression analysis with the raw predictor. It would be that for every additional year a participant has been smoking, we would expect a 0.738 increase in the number of cigarettes smoked. So in conclusion, centering our predictors at the mean has no impact on the f-test, the p-value for the f-test, the p-value for the B1 coefficient, or the r-squared effect size. It just changes the intercept from a nonsensical value to the mean of the outcome variable. And then the centered regression model stays the same. It's the mean plus the independent variable plus some error. But now we really can't say that it's the mean as opposed to being some nonsensical intercept estimate. This concludes the 5th lecture on linear regression. In the next lecture, I'll describe regression analysis with more than one predictor.